Section 3.5 is about rational function and their graphs. A rational function have the form is r of x equal to p of x and q of x. In this case, both p of x and q of x are polynomials. So it's a polynomial divided by polynomial. Now we're going to look at some notation. This one says x approaches a from the left hand side because it's coming negative. You also have one thing that comes on the right hand side, the positive. This is x approaches infinity. That means it's increasing without bound. This is negative infinity. So that means it's decreasing without bound. So if you're working with rational numbers and you're working with positive numbers, if you divide 1 by a big number, you get a small number, or if you divide 1 by a small number, you get a big number. Okay. So this is a sketch graph of x 1 over x. So you have two different distinct graphs over here. This dotted line represents something called asymptote. You have a vertical asymptote and a horizontal asymptote. In both those vertical and horizontal asymptote, the graph will come really close to it, but it will never touch it or go over it. Okay. So in the previous graph, there's a vertical asymptote at x equals 0, 1. So basically, we're looking at this. If I'm looking at the graph from the left-hand side, where is my function going to? And say for the same thing, for the right-hand side, where is the graph going to? So in here, as x approaches 0 from both left or right, the f of x will go to either negative infinity or positive infinity. Same thing with the horizontal asymptote. In this case, there's a horizontal asymptote of x equals 0. So with horizontal asymptote, we look at the opposite. As x approaches infinity, what happens is my function f of x. In this case, it goes to 0. So if you want to look at a horizontal asymptote, one way to look at it is a type of end behavior. So let's look at this. In order to find the vertical asymptote, you look at where the denominator is 0. So basically, we factor the denominator to find them. And here, this is a problem x minus 1, x squared minus 1, factor x squared minus 1. And here we cancel these out. So you're left with 1 over x plus 1. Solve for x, we get negative 1. So the vertical asymptote is at x equal negative 1. And we always represent asymptote with a dotted line. So in here, the graph of 1x. So in this case, the graph is shifted by left by 1. But there's a hole over here. And this x equal 1 is not in the domain. Now, finding vertical asymptote is really easy. When it comes to horizontal asymptote, you had to look at 3 different cases. You have where the degrees of P and Q are equal. So let's say the P has a degree of n, Q has a degree of m. If they're equal, like this problem, 5x squared plus 3x x minus 1 divided by 3x squared minus 1. If we only look at the leading degrees, in here they have the same term, same degree, 2 and 2. So you just divide the numbers 5 over 3. If the one on the top, if n is smaller than the bottom, then it doesn't matter what those numbers are, the horizontal asymptote is always at 0. If the one on the bottom, and if on the top is higher than the one on the bottom, then you have no horizontal asymptote. So the 3 distinct cases of horizontal asymptote are you either have no horizontal asymptote, or you have one at y equals 0, or you have it at where the quotient of the leading term. You also have a special case like this. Your n is equal to m plus 1. So 2 is equal to 1 plus 1. This is not a horizontal asymptote. So we know that in this case, there's a horizontal asymptote because the one on numerator higher than the one on denominator. But this special format is called client asymptote, or that's another word. So in order to just do a synthetic division, you get this and this quotient line. This quotient you get is a line for the client asymptote. Yeah, these are the guidelines for graphing a rational function. Find the x and y intercept. Find any asymptote if there are. Make a table of points, include the x-intercept, and at least one point between or beyond each x-intercept and vertical asymptote. Plot the points and connect them with a smooth curve of the right shape. Here's the problem. Divide 12x plus 12 divided by x squared plus x minus 6. Factor them. So in this case, you can find the x-intercept. So x plus 1 equals 0. You get x equal to -1. Y-intercept is where this is equal to 0, so it's at -2. Vertical asymptote is where your denominator is equal to 0. So you have x equal to 3, -3, and x equal to -2. Since the degree on the denominator is higher than your degree on the numerator, your asymptote, horizontal asymptote is y equals 0. So then you find the points. You have -4 and -6. Both -3 and 2 are undefined. That's your vertical asymptote. And you have these points. Then you graph them. If this dotted lines are your vertical asymptote, and the dotted line of the x-axis is your horizontal asymptote. Okay? Another problem, x squared minus 3x minus 10. Find the x-intercept. So you have x is going to go 2, so 5. Find the y-intercept for 0 and 10. The vertical asymptote is at 1, so this was 0. You have no horizontal asymptote because the degree on the numerator is higher. But this is a special class, a slide asymptote. When you divide them, you get this x minus 2. So you make the points and you graph it. This is section 3.5.